In this video, we're going to talk about how to take the name of an acid and convert it back to the chemical formula. As you remember in our previous videos, you can see here on the screen, we took the chemical formula and we wrote the name of the acid. So now we're just going to look at these 6 right here and how to convert from the name back to the chemical formula. So just to review real quickly, our last video I talked just briefly about this, about that when you're starting with the name and you're writing the chemical formula, we talk a little bit about this whole hydro in the front, okay? Because that hydro is really, really important. Remember that if it starts with hydro, it means it's a binary acid, which means you're looking for the element on the periodic table. Okay, rather than looking at those ions, those 10 polyatomic ions we learned earlier with ionic compounds, anytime the acid starts with hydro, again, we know it's binary and we know that it has to therefore come from the periodic table. So when I see hydroselenic acid, I'm going to the periodic table and I'm looking in that non-metal section for an element that starts with selene, and hopefully it just kind of becomes familiar that selenic comes from selenium. Okay, and so I look at selenium on the periodic table and I go, oh, selenium is in the -2 column. It's below oxygen. So it's Se2-. So therefore, when we write the name or the formula for that acid, we have to cancel out that -2, and so we write H2Se, and that would be the formula of hydroselenic acid. Okay, with hydrosulfuric acid, again, it starts with hydro, so as soon as you see hydro, you think periodic table. And sulfuric obviously comes from sulfur, and sulfur, like selenium, also has a -2 charge. So that is also going to be H2, and then in this case, just S. Okay, and then the last one that starts with hydro, and then I'm going to do just a couple more. Hydrophosphoric means it had to, again, come from the periodic table. So phosphoric had to come from phosphorus, and phosphorus is P with a -3 charge. So it would be H3P. Okay, now let me just do 1 or 2 more here. So if we look at, for example, hydrochloric acid. I think we've seen this one before, but just to make sure. Okay, it starts with hydro. That means it has to come from the periodic table. Chloric comes from chlorine, and chlorine is Cl, and it has a -1 charge. It's below fluorine. And again, just a reminder here that on this side of the periodic table, here's the noble gases, there's 0, and then it goes -1, -2, -3. So fluorine, everything fluorine down is -1, oxygen is -2, and nitrogen down is -3. So chlorine is below fluorine, so it has a -1 charge, so we need 1 hydrogen to cancel that out, and we get just HCl. So again, anytime an acid starts with the word hydro or with the prefix hydro, you go to the periodic table, you use the element, not the ions from earlier with the ionic compounds. Now, for all the other ones, though, what if it doesn't start with hydro? What if it's just carbonic acid or acetic acid or nitric acid? Then that means don't look at the periodic table. It means it had to come from your polyatomic ion list. So carbonic means it had to have come from carbonate. Okay, all of the ones that end in ATE become IC at the end. Okay, so if it's carbonic, it means it was carbonate. Okay, so carbonate is what carbonic acid had to have come from. And so carbonate, if again, go back up and look at it, it's CO3 2-. And so to cancel that -2 charge, we need 2 hydrogens. So we get H2CO3. Then acetic acid. Acetic acid means it had to have come from acetic, means it came from it's hard to say that way. Acetate is what it came from. Okay, and acetate, again, go back and look at it, is C2H3O2 with a -1 charge. So with a -1 charge, it means we put one hydrogen in the front, and then we put just the C2H3O2. Okay, and then our final one is nitric acid. Nitric came from nitrate, and nitrate is NO3 minus, and therefore it is just HNO3. Okay, so really the key here, guys, is there a hydro in the front or is there not? If there's a hydro in the front, you have to use the periodic table. You use the element from the periodic table. Okay, if it doesn't have hydro in the front, then you use your ions from the list of ions earlier when we talked about ionic compounds. Okay, and again, this is a good example of why that's important, because hydrochloric acid, as we just said, was HCl. Because it has a hydro in the front, then if we go to the periodic table, it has to be chlorine. But chloric acid does not have hydro in the front, which means it has to be one of our polyatomic ions. So chloric acid came from chlorate, and chlorate is ClO3 minus. So then chloric acid is HClO3. Okay, and that is how you take the name of an acid and turn it into a chemical formula.